Bamboo is the most decorated plant on the planet. Over 1,500 species, found on every continent except Antarctica and Europe. Used by more than 2.5 billion people every single day for everything from food to shelter to the scaffolding on 60-story skyscrapers in Hong Kong. It sounds like the ultimate success story. At least, that's what everyone thought. Because the thing that makes bamboo one of the most useful organisms in human history is the same thing that makes it one of the most destructive. And the biology behind it is so strange that scientists spent over a century arguing about whether bamboo was even a real plant or something else entirely. If you'd asked any botanist in 19th century Europe about bamboo, they would have told you it was a tropical curiosity. Something exotic, maybe useful for garden furniture or walking sticks, but nothing that demanded serious scientific attention. They had no idea. Because bamboo isn't a tree, it looks like one. It grows taller than most of them. Some species in the tropical forests of Southeast Asia reach over 30 meters, roughly the height of a 10-story building. You could spend your entire life around bamboo and never question whether it belongs alongside oaks and maples and pines. It doesn't. Bamboo is a grass. It belongs to the same biological family as the wheat in your bread and the rice on your plate and the corn growing in fields across the American Midwest. The family is called Poaceae, and bamboo is its most ambitious member by a wide margin. The fossil record backs this up. Bamboo has been around for a long time. Paleobotanists have found bamboo fossils in Patagonia, at the southern tip of South America, dating back tens of millions of years. Some researchers believe bamboo's ancestors were already growing during the late Cretaceous period, which means this grass was sharing the planet with dinosaurs. It watched the asteroid hit, it watched the dinosaurs disappear, and it kept growing. What allowed it to survive that long is buried underground. Beneath every bamboo grove sits a network of rhizomes, thick horizontal stems that spread through the soil like a root highway. These rhizomes are the real organism. The tall green culms you see above ground are just the visible part, like the tips of an iceberg. A single rhizome network can cover acres of forest floor. And technically, that entire network is one plant. One interconnected organism, quietly expanding underground, sending up new shoots whenever conditions are right. That underground network would turn out to be the key to everything that makes bamboo both miraculous and dangerous. But that comes later. First, the growth. Because the speed at which bamboo grows above ground is where the story gets genuinely weird. The species Philostachys edulis, commonly known as mosso bamboo, holds some of the most absurd growth records in the plant kingdom. Researchers in Japan documented a single mosso bamboo shoot growing 91 centimeters in 24 hours. That's not a typo, by the way. Nearly a full meter in one day. To put that in perspective, a typical oak tree grows about 30 centimeters in an entire year. Bamboo can match that before lunch on a Tuesday. This is where the story takes a turn nobody expected. Because the mechanism behind this growth doesn't work like any other plant on Earth. Most plants grow from their tips. A tree adds height by producing new cells at the very top of its trunk and at the ends of its branches. It's a slow, careful process. The tree builds its structure one layer at a time, adding rings of wood and bark year after year, decade after decade. Bamboo doesn't do any of that. A bamboo culm grows from multiple points simultaneously. At every joint along the stalk, every single node, there's a band of tissue called an intercalary meristem. Each one of these bands is an independent growth engine. So while a tree has one point of growth, a bamboo culm can have 40 or 50, all of them extending at the same time. Imagine an accordion being pulled open. Every fold stretches at once. That's bamboo. I mean, think about that for a second. The entire structure is elongating from dozens of points simultaneously. No other plant does this at bamboo's scale. And it gets stranger. When a bamboo shoot first pushes out of the soil, it already contains every single cell it will ever have. A tree spends years producing new cells to grow taller. Bamboo skips that step entirely. The cells are pre-formed inside the compressed shoot from the moment it emerges. All the shoot needs to do is inflate them. It does this through turgor pressure. Water floods into the pre-formed cells, expanding them rapidly, like filling thousands of tiny balloons at once. The shoot doesn't need to wait for cell division. It doesn't need to slowly manufacture new biological material. It just pumps water in and stretches. This is why bamboo can grow a meter in a day, while an oak manages a centimeter in a month. The oak is building from scratch. Bamboo built everything in advance and is just unfolding it. There's one more piece to this. Growing that fast creates a structural problem. If you inflate a tall, thin tube rapidly, it should snap under its own weight. Bamboo solves this by depositing silica into its cell walls during expansion. Silica is essentially glass. It hardens the walls of each cell as they stretch, providing rigidity without the slow, dense wood production that trees rely on. It's the biological equivalent of reinforcing a skyscraper's frame while it's still being lifted into place by the crane. The same biology that made bamboo so resilient was about to reveal something that breaks every rule botanists thought they understood. Because bamboo didn't evolve this speed just to impress scientists, it evolved it to survive something far more desperate. Deep in the tropical and subtropical forests where bamboo first evolved, sunlight is the single most valuable resource. The canopy overhead is thick, often so dense that less than 2% of available light reaches the forest floor. For most plants, that's a death sentence. You either find light or you die. Trees solve this problem slowly. They grow upward year after year, adding wood, thickening their trunks, gradually muscling their way into the canopy over decades. Some hardwoods take 50 or 60 years to reach full height. That strategy works, but it's a gamble. You're investing decades of energy before you ever collect a real return on sunlight. Bamboo chose a completely different bet. Instead of growing slowly and building a fortress, bamboo races. It throws everything into vertical speed, reaching the canopy in weeks instead of decades. The calm doesn't bother developing thick bark or deep protective wood layers. It doesn't need to. By the time a competing tree has added 6 inches of height, the bamboo is already up in the light, photosynthesizing at full capacity and sending energy back down to the rhizome network underground. It's a sprint strategy in a world full of marathon runners, and for millions of years, it worked. But here's the detail that everyone missed at the time. Bamboo's speed came with a cost that nobody fully understood until it triggered a catastrophe. Bamboo flowers. Every plant does. But bamboo does it in a way that still baffles biologists. Some bamboo species only flower once in their entire lifespan, and that lifespan can stretch anywhere from 60 to 120 years, depending on the species. When the flowering finally happens, every individual plant of that species across the entire world flowers at the same time. It doesn't matter if one plant is growing in a forest in southern China and another is in a botanical garden in London. They flower together, on the same schedule, synchronized across continents. And then they die. All of them. The entire generation. Gone. Scientists still argue about how this synchronization works. The leading theory involves an internal genetic clock, a countdown timer built into the plant's DNA that triggers flowering after a fixed number of years, regardless of local conditions. But nobody has proven it conclusively. What is proven is what happens next. When bamboo flowers, it produces an enormous volume of seeds, and those seeds attract rats. In the bamboo forests of northeast India, particularly in the states of Mizoram and Manipur, this cycle has been documented for centuries. The bamboo flowers. The rats come. The rat population explodes because of the sudden, massive food supply. And when the bamboo seeds run out, the rats turn to the nearest alternative food source. The grain stores in nearby villages. Entire communities would look back on this and wish they'd paid attention to what the bamboo was telling them. The result is famine. It happened in the 1840s, and the local Mizo people called it Mautam, which roughly translates to bamboo death. It happened again in 1891, and again in 1959, and again around 2007. Every time, the same pattern. Bamboo flowers, rats swarm, crops disappear, people starve. For centuries, colonial British administrators dismissed these famines as superstition. The idea that a plant's flowering cycle could predict a famine sounded absurd. It wasn't until the mid-20th century that researchers confirmed the connection was real and measurable. The bamboo had been signaling disaster all along. That connection between bamboo and human survival would come back again and again throughout history. But that's getting ahead of the story. Because long before bamboo was causing famines, humans figured out how to turn it into one of the most versatile materials civilization has ever known. The earliest recorded uses of bamboo trace back over 7,000 years in China. Before paper existed, the Chinese wrote on thin strips of bamboo tied together with cord. These bamboo slips were the original books. Some of the oldest surviving texts in Chinese history, including early versions of Confucian philosophy, were written on bamboo and buried in tombs. But bamboo wasn't just for writing. Ancient Chinese engineers used bamboo pipes to transport natural gas from wells to nearby salt evaporation facilities. This was happening over 2,000 years ago. Hollow bamboo culms, sealed at the joints with mud and cloth, carried flammable gas across miles of terrain. Basically, the world's first natural gas pipeline was made of grass. In Japan, bamboo became central to an entirely different kind of culture. The tea ceremony, one of the most refined artistic traditions in Japanese history, relies on bamboo utensils. The whisk, the ladle, the flower container, bamboo architecture influenced Japanese design philosophy for centuries, emphasizing flexibility and lightness over brute strength. The same material being used as plumbing in China was being treated as high art across the sea in Japan. Then Thomas Edison got involved. In 1879, Edison was desperately searching for a filament material that could make his incandescent light bulb commercially viable. He tested over 6,000 different materials: platinum, cotton thread, fishing line, even hair from a colleague's beard. Nothing lasted long enough. The filaments either burned out in minutes or couldn't produce enough light to be useful. Edison's team eventually carbonized a strip of bamboo from Kyoto, Japan. They baked it at high temperatures until it turned into a thin carbon filament, then sealed it inside a glass vacuum bulb. It burned for over 1,200 hours, the most important piece of grass in industrial history, and it lit up the world. So yeah, not exactly what you'd expect from a relative of your front lawn. And bamboo's resume didn't stop in the 19th century. Walk through Hong Kong today and look up at the skyscrapers under construction. You will see bamboo scaffolding wrapped around buildings 60 and 70 stories tall. Not steel, not aluminum, bamboo. Crews of experienced scaffolders can erect a bamboo framework faster than a metal alternative. And during typhoon season, the flexibility of bamboo actually outperforms rigid steel scaffolding. Steel bends and stays bent. Bamboo flexes and snaps back. In a city that gets hit by tropical storms every year, that difference matters. You'd think someone would have said something about this earlier. Nobody did. The global construction industry spent most of the 20th century ignoring a building material that had been proving itself for millennia. If you're finding this interesting, hit subscribe. I cover deep dives like this on nature, history, and science every week. By the early 2000s, bamboo had spread far beyond its native range, and not everyone was happy about it. The same rhizome network that makes bamboo so resilient in the wild makes it a nightmare in the wrong setting. Homeowners in the southeastern United States learned this the hard way. Golden bamboo, originally imported as an ornamental garden plant in the early 1900s, turned out to be one of the most aggressively invasive species ever introduced to North American soil. The rhizomes don't care about property lines. They spread underground, sometimes 12 meters or more from the original planting site, and send up new shoots on the other side of fences, driveways, and foundations. In some documented cases, bamboo rhizomes have cracked through concrete basement walls, they've lifted patios, they've invaded septic systems, and removing established bamboo is brutally difficult. You can cut every visible culm to the ground, and the rhizome network underground will simply send up new shoots within weeks. Herbicides work slowly, and often damage surrounding plants. Full excavation of the rhizome system can require heavy machinery and cost thousands of dollars. Some property owners have spent years fighting bamboo that a previous owner planted as a decorative screen. The legal fallout has been significant. Multiple states now have laws specifically addressing bamboo. In some jurisdictions, planting certain running bamboo species near a property line without a containment barrier is grounds for a lawsuit. Councils in parts of England and Wales have flagged bamboo as a potential issue in property surveys, similar to Japanese knotweed. And then, bamboo made the one decision that changed everything. Or rather, it didn't make a decision at all. It just did what it's been doing for tens of millions of years. It grew, fast, relentlessly, and without any regard for the plans humans had made around it. The plant that built Edison's light bulb and held up Hong Kong's skyscrapers was now destroying suburban patios in Georgia. The same biological engine, the same rhizome network, the same cellular speed, just pointed in a direction nobody wanted. Up to this point, bamboo had been both hero and villain in the same story. But stack it against the materials humans actually rely on every day, and the numbers get uncomfortable. Start with speed. A hardwood oak takes roughly 40 years to reach harvestable maturity. Teak takes 25. Bamboo can be harvested in 3 to 5 years, depending on the species. Some commercial operations in southern China cut mosso bamboo at the 4-year mark and replant nothing. The rhizome network sends up replacement shoots on its own. You harvest the culm, and the factory underground just builds another one. Now compare strength. Bamboo has a higher tensile strength per unit weight than structural steel. That sounds like something someone made up, but it's been tested repeatedly in materials science labs. The combination of long parallel cellulose fibers and silica-reinforced cell walls gives bamboo a strength-to-weight ratio that engineers have started taking seriously only in the last 2 decades. A bamboo culm can bend nearly to the ground in a storm and snap back upright without cracking. Try that with a steel beam. Carbon footprint is where things get really interesting. Producing 1 ton of steel generates roughly 1.8 tons of carbon dioxide. Producing 1 ton of concrete releases about 1 ton. Bamboo, on the other hand, absorbs carbon dioxide as it grows, up to 12 tons per hectare per year in well-managed plantations. The material you're building with is actively pulling carbon out of the atmosphere while it's alive. And even after harvest, the carbon stays locked in the bamboo product for the duration of its useful life. A bamboo floor panel or structural beam is functioning as a carbon sink sitting in your building. Then there's the water comparison. Cotton is one of the thirstiest crops on Earth, requiring roughly 10,000 liters of water to produce a single kilogram of fabric. Bamboo fiber production uses roughly a third of that. Bamboo-derived textiles have been growing in the fashion and bedding industries for years, marketed as a sustainable alternative. Though it's worth noting that the chemical processing required to turn raw bamboo into soft fabric involves solvents that aren't exactly gentle on the environment. The raw material is green. The manufacturing process, not always. What comes next is the part that still doesn't make sense. Despite all of these advantages, bamboo remained a niche material in Western construction and manufacturing for most of the 20th century. Entire industries built around steel, concrete, and hardwood timber operated for decades without seriously evaluating bamboo as a competitor. The research existed. The test results were clear. The adoption just didn't follow. Part of the problem was perception. In Europe and North America, bamboo carried a reputation as something decorative: garden screens, furniture, tiki bars. Nobody looked at a bamboo culm and saw a load-bearing column, even though billions of people across Asia had been using it as exactly that for centuries. That's starting to change now. In East Africa, bamboo is being called the continent's green gold. Ethiopia alone has over 1 million hectares of natural bamboo forest, the largest bamboo reserve in Africa. Organizations working across Kenya, Uganda, and Tanzania are developing bamboo-based industries from scratch, producing everything from building materials to charcoal briquettes to woven household goods. For rural communities where timber is scarce and expensive, bamboo offers a construction material that grows locally, renewably, and fast enough to keep pace with demand. International development groups have pointed to bamboo as one of the most promising tools for reforestation and land restoration. Degraded hillsides and eroded slopes can be stabilized with bamboo plantations that establish root networks within a single growing season. In parts of southern China and northern India, bamboo has been used to reclaim land that was essentially barren after decades of deforestation. The Rhizome network that terrorizes suburban homeowners in the United States is, in a different context, holding entire mountainsides together. Bamboo-based alternatives to plastic are gaining traction too. Bamboo toothbrushes, bamboo cutlery, bamboo fiber packaging. The market for these products has grown significantly over the past 10 years, driven partly by consumer demand for sustainable alternatives and partly by regulatory pressure on single-use plastics in the European Union and parts of Asia. But there's a catch, and this matters if the story is going to be honest. Not every bamboo product is as green as its marketing suggests. Bamboo monocultures, where vast plantations grow a single species for commercial harvest, carry many of the same ecological risks as any other monoculture farming. Reduced biodiversity, soil depletion, vulnerability to disease. A bamboo plantation is not a forest. It supports a fraction of the wildlife that a natural mixed woodland does, and the processing question is real. Turning raw bamboo into fabric, paper, or engineered lumber often requires chemical treatments, adhesives, and energy-intensive manufacturing. A bamboo cutting board sitting on your kitchen counter went through a factory before it got there. The carbon math only works if the entire production chain is accounted for, not just the growing phase. The most credible researchers in this space are careful about the distinction. Bamboo the plant is extraordinary. Bamboo the commercial product depends entirely on how it's grown, processed, and transported. Calling every bamboo product sustainable without examining the supply chain is exactly the kind of shortcut that gets industries in trouble. Still, the trajectory is clear. Global bamboo trade is worth over $70 billion annually and growing. The International Bamboo and Rattan Organization, which coordinates policy across member countries, has pushed for bamboo to be included in national climate commitments under the Paris Agreement. Several countries have started counting bamboo plantations toward their reforestation targets. The grass that was sharing the planet with dinosaurs is now showing up in United Nations climate documents. And that brings everything full circle. Bamboo started as a survival strategy, a grass that figured out how to outrun every competitor in the forest by growing faster than anything else alive. It evolved a cellular engine so efficient that it skips the slow, careful process every other plant relies on. It built an underground network so resilient that it survived mass extinctions. And then humans found it and spent 7,000 years turning it into books, buildings, light bulbs, scaffolding, and lawsuits. The real question isn't why bamboo grows so fast. It's why we took this long to pay attention to something that's been quietly outperforming everything around it for 60 million years. If you want to see how another organism pulled off something this unlikely, that video is on screen now.